Good morning, students. As we have discussed in last class about canal sections, I am here with the second topic of this unit, that is canal lining. I have prepared a small presentation for you all. In this, the whole presentation is divided into four parts. First one is objective of providing canal lining. Second one is the types of lining, means what are the type of material we use in canal lining. Third one is advantages and disadvantages of providing canal lining. And last one is the economics about canal lining. So as we have discussed, the canal cross section is being designed such as to carry the water at FSL, that means full supply depth. And we have also discussed about various cross sections, various components of a canal, that means a canal, berm, a bank, a counter berm, spoil banks, margins, etc. So the first topic about canal lining is objective of providing canal lining, means why we are providing lining of the canal, why it is necessary to line the canal. So the objective of providing canal lining is, first one is divided into these parts. First one is to control the seepage. As we have discussed in last class, that the seepage loss is the maximum amount of loss or major losses that we see in unlined canals, and due to which we determine, due to the loss of seepage or due to the seepage loss, we determine the hydraulic gradient line. And that hydraulic gradient line or that seepage is caused due to the property of the soil being permeable. And we have to also fix that the hydraulic gradient line should not cross the heel of the bank. These all points we have discussed earlier. So this type of loss is the maximum losses that we see in unlined canals. Means if your canal is being lined means it means being covered by some certain material, then the amount of water that would seep would get reduced, and due to which the duty of the canal would increase. What is duty? We have discussed in irrigation chapter number 1, irrigation. The duty is the amount of water that is required by a particular crop for its ideal growth. Therefore, if seepage would occur, the duty of canal would get reduced, and hence the amount of water that is being provided to agricultural land would reduce. So if we would not line the canal, we would not be able to control the amount of seepage. Okay. This you can see, the first picture is the loss which we will see due to seepage. This is a diagram which is showing about seepage. This is your this is a diagram that is showing the flow of water through the canal. And what we have done to prevent the seepage loss, we have lined the canal to prevent the seepage loss. So the first objective of providing the canal lining is to control the seepage. So the most important portion of canal lining or providing canal lining is to control the seepage. Next one is to prevent waterlogging. This point is connected to the previous point. That means if the canal is not lined, then seepage would occur, and if seepage would occur, that water would get outside of the canal and get collected into low-lying areas and hence create marshy lands. What are the disadvantage of marshy lands? Marshy lands would harm the growth of the plants and would also occur the breeding of the mosquitoes. Okay, so to prevent the waterlogging and to control seepage, we have to line the canal. Next one is to increase the capacity of the canal. In unlined canal, we have observed that the velocity of the flow should be fixed. That means the velocity of the flow is lower in case of unlined canal, and to reach a certain amount of discharge, we have to provide a larger cross-sectional area. As we know that discharge is equals to area into velocity. That means if the velocity is low, then to maintain a certain amount of discharge, we have to increase the cross-sectional area. So if the canal is not lined, that means it is not lined means a smooth surface is not provided, therefore the velocity of flow is less, and since the velocity of flow is less, the larger cross-sectional area of a canal would only result in a high amount of discharge. Therefore, the most important point here is that if we would line the canal, we can increase the capacity of the canal. Okay, like this. Okay, we know that the discharge is equal to area into velocity. If the velocity is low, then if we want to get a certain amount of discharge, means discharge is what? Volume flowing through a canal per second. Okay, so we need to increase the area of cross section. That is not economical, therefore we provide lining of the canal. Same is to increase the command area. What amount of area is being irrigated by a per meter cube per second? Means 1 unit of discharge is irrigating how many hectares of area? That is, if the canal is lined, then the velocity would be increased. The velocity would be increased, then a lower cross-sectional area would result in high amount of discharge and more amount of area would be irrigated. Next one is to get the protection from flood. The unlined canals, if I compare a lined canal and an unlined canal, the unlined canal may cause severe damage when a high amount of water is being carried over through the canal, since rainwater is in the form of precipitation, and if a large amount of water is being carried through the canal with high velocity, that causes the scoring and the erosion of the soil materials in the particular, which can be seen only in the case of unlined canal. When the canal is lined, this particular effect is being reduced. Last one is to control the growth of the weeds. If your canal is not lined, then unnecessary plants would grow up. That would cause hindrance to the flow of water through the canal, and hence velocity would get reduced, discharge would get reduced, and in that case we require a larger cross-sectional area to get a desired amount of discharge. As you can see in this type of diagram, this is a case of unlined canal, and due to not lining of the whole canal, these type of weeds have been produced, and if now the flow of water would carry the water to flow, then the velocity would get reduced, and velocity would get reduced, the discharge would get reduced. For example, if you require 10 meter cube per second a discharge at one side, then due to the growth of weeds, the velocity would reduce and the discharge would also be reduced. Okay, so these are the objectives of providing canal lining. Next, we have what are the types of lining that are in common use. First one is cement concrete lining. Second one is precast concrete lining. Third one is cement mortar lining. Fourth one is lime concrete lining, brick lining, boulder lining, asphalt lining, bentonite and clay lining, soil. So these are some common type of lining that is being showed. First one is concrete lining, second one is masonry, third one is your compacted clay or soil lining, soil cement. So we need to understand where and in what cases we use which type of lining. I have here mentioned about cement concrete lining, precast, cement mortar, lime concrete, brick lining and boulder. First one is your cement concrete lining. The most important part of the cement concrete lining is that it is always used when your canal is being constructed in full type of banking. I have discussed in previous class that the canal banks can be of three types: full banking, full cutting, partial cutting and partial banking. So when you have a canal bank in full banking, then we use cement concrete lining. It is the best impervious lining. It also resists the effect of scoring and erosion effectively. The velocity is usually 2.5 meter per second and above. The most important advantage of this type of lining is that it completely eliminates the growth of weed. Okay, so the process of providing the cement concrete lining is in two parts. First one is to prepare the subgrade. Like in pavements, we prepare the subgrade, then we put on sub base layer, and wearing course. Like in this also, while laying out the lining, we first of all prepare the subgrade. And how the subgrade is prepared, please note down. The subgrade is prepared by providing a sand layer and compacting that sand layer. That sand layer would be 15 centimeter thick, and above that a slurry of cement and sand. A slurry of cement and sand in the ratio 1:3 is spread to give a certain base. Okay, so how is the preparation of subgrade is done? We would put on 15 centimeter thick layer of sand, and over this a slurry of cement and land of ratio 1:3 is uniformly spread to prepare the bed. Okay, above that concrete is being laid, and which concrete is M15 grade concrete is laid. M15 concrete is laid, and what would be the thickness? The thickness is 100 mm to 150 mm. Okay, curing is done for 2 weeks. Like we provide pavements in cement concrete, we always provide expansion joints. Why? Because the concrete has certain effects of temperature. Okay, so here also we would provide expansion joints, and these expansion joints are filled with bitumen. So we use M15 grade concrete. And what is the thickness of this concrete slab? Cast in situ 100 mm to 150 mm. Curing is done, and certain expansion joints are provided. So the subgrade is prepared by providing 15 centimeter thick layer of sand, and over this a slurry of cement and sand 1:3 ratio is prepared, and above this cement concrete of M15 grade is provided along with expansion joint, and this expansion joints are filled with bitumen. Okay, the next lining which we are going to discuss is precast concrete lining. So this you have to note down the important points. That means the first one is this type of lining is also provided in full banking. Okay, the full banking, and we would have a precast concrete slab of size 60 centimeter cross 60 centimeter cross 5 centimeter, and it would be used. The subgrade, it would be prepared as we have prepared in last type of lining, cement concrete, and 15 centimeter thick sand layer is compacted, and above that this slurry of cement and sand is 1:3 is poured. Along with that, the precast concrete slab is placed with cement mortar 1:3, and again the joints are finished. The slabs are connected with certain joints, and these joints are finished with 1:3 cement mortar, and for that curing is done for 1 week. Okay, so this is a typical diagram of a precast concrete lining. Next we have cement mortar lining. The first two type of lining were used in full banking. This type of lining is used in full cutting. Okay, this type of lining is usually 2.5 centimeter thick. Okay, the subgrade when I say subgrade, that means I mean about the surface of the canal at which we need to provide the lining. Okay, as in the roads, the cement mortar lining would be 2.5 centimeter thick, and the cement mortar which we would be using is of ratio 1:4, means 1 part of cement and 4 part of sand. The subgrade is prepared by a particular compaction. It is impervious, but it is not durable. The above two type of lining were best impervious and durable also. Okay, but in this type of lining, it is impervious but it is not durable. That means we have to maintain this type of lining. Maintenance cost would be increasing, and in this type of curing is done also. Okay, so we have discussed about cement concrete lining. Okay, this is a particular figure of cement mortar lining. We have discussed about cement concrete lining, we have discussed about precast concrete lining, and we have also discussed about cement mortar lining. Next we have lime concrete lining. Next we have lime concrete lining. Generally this type of lining is used when hydraulic lime, surkhi and brick ballast are available in plenty at the site. Okay, the lime concrete is prepared of ratio 1:1:6. Usually this type of lining is of thickness 150 mm to 225 mm. It is also impervious but less durable than cement concrete lining. So we have to keep in mind that the most durable lining is cement concrete lining and precast concrete lining. And again, the cement mortar lining and lime concrete lining both are used in full cutting. Okay, and the both type of lining are not durable, therefore maintenance has to be done. Okay, next type of lining is brick lining. In this type of lining we use first class brick, and we use a double layer of brick. And how it is being kept, how it is being stacked, how it is being joined, it is joined with cement mortar 1:6. the surface, the topmost surface of the lining is finished with cement plaster 1:3. It is most economical. Another advantage is that it is expansion joints are not required as in cement concrete lining. Here repair work is done easily because repair work is done easily as there are no expansion joints, and you can, for example, if a particular patch is being damaged, then you have to replace that patch. It is easier in comparison to cement mortar lining or lime mortar lining. Okay, it is not durable, but it is less as resistant to, it is also less resistance to erosion, and it is not impervious also. So this type of lining is only used when economical portion comes into action. Economical is the advantage, expansion joints are not required is the advantage, repair work done easily is the advantage. It is not durable, it is not impervious, and it is less resistance to erosion. This is a diagram which is showing a brick lining. It can be used in full cutting also, and it can be used in partial banking and partial cutting also. Okay, so this is a canal which is being constructed in partial banking and partial cutting. Okay, next we have boulder lining. In boulder lining, we have a single layer of boulder or a double layer of boulder which is being joined with the subgrade with cement mortar 1:6 ratio. That means 1 portion of cement and 6 portion of sand. And this particular layer of boulder is being finished with cement mortar 1:3. It is durable also and it is impervious also. This type of boulder lining is also used in full banking. As you can see in boulder lining, that this type of canal is in full banking, and the boulder layer is being spread over the subgrade with cement mortar 1:6, and the topmost layer of this boulder layer is being finished with cement mortar 1:3. Like this also, I have mentioned we also have asphalt lining. In asphalt lining, we use bitumen spread at high temperature 150 degrees Celsius, and it is also used with thickness 3 mm to 6 mm. Like same bentonite and clay, we have a mixture of bentonite and clay that would create a sticky mixture, and we would spread it on the subgrade. And same we have a soil cement lining. In soil cement lining, the percentage of cement that could be used for treating the subgrade is 10%. Okay, so these are the common type of lining that we use for the canal surface. Okay, cement concrete lining, precast, cement mortar, lime concrete, brick lining, boulder lining, asphalt, bentonite clay, soil cement lining. Next, we have to discuss what are the advantages and what are the disadvantages of the canal lining. We have discussed earlier also what are the objectives of providing canal lining that are disadvantage that we are converting into advantage by providing the canal. So the first advantage is reducing loss of water. That means reducing the amount of seepage, reduce control waterlogging. We have discussed earlier. It provides a smooth surface. By providing canal lining, as you can see, why we provide a wearing surface at the pavement to provide a smooth riding surface. Like in this also, for the flow of water through the canal, we require a smooth surface. The smooth surface would increase the velocity of flow. The increased velocity of flow would increase the discharge. Okay. Next is it would eliminate the effect of scoring. Scoring means washing away of soil particles from the canal bed. Okay. If the canal bed is not lined, the the material of the soil would get washed away and would get transported from one point to another point. It also eliminates silting. It also prevents growth of weed, and it also provides a stable section. Stable section means by lining you can see that your canal is being of a certain shape and certain size, and above losses, that means seepage loss, discharge is increased, and growth of weeds is prevented, and therefore that would result in less maintenance cost. What are the disadvantages of canal lining? Canal lining is having a disadvantage that the initial cost of providing the canal lining is high, and it is also a time taking process, and it is very difficult to repair a damaged section of lining. That would cause a high maintenance cost. Okay, maintenance cost is less, but it is difficult to manage, difficult to repair the damaged section of the line. So these are the advantages and disadvantages of canal lining. Next is the economics of the canal lining. That means how a canal should be designed, and why a canal should be designed, of what capacity it should be designed. So there are two factors which we need to understand. That first one is cost of the canal lining, and second one is what are the benefits of the canal lining. What does cost includes? Cost includes, first is annual depreciation charge. This annual depreciation charge is being calculated by calculating what is the initial cost that is being invested in the canal lining and what is the life of the canal. Okay, the ratio of the initial cost to the life of the canal gives you annual depreciation charge. This is, for example, say X. Second point in calculating the cost of the canal lining is average annual interest. This average annual interest is being applied on the initial cost and with a certain rate of interest. For example, this annual rate interest is Y. So the average annual cost would be X plus Y for a particular canal lining. What would be the benefits? As we know that what are the disadvantages of not providing, what are the advantages which we get from providing canal lining? First of all, we would eliminate the seepage cost. So amount of water that would be get lost when lining is not provided, we are saving that amount of water by providing canal lining. So the saving which we get by eliminating seepage is S1, and saving we would also save certain maintenance costs. The saving in maintenance cost is, for example, S2. So for example, saving by eliminating seepage loss is S1, and saving in maintenance cost is, for example, S2. How is it? This is a benefit. If we provide lining of the canal, the maintenance cost is reduced. For example, growth of weeds, for example, seepage, these all would result in saving the maintenance cost. That is a benefit. Now if we compare a lined canal and an unlined canal, so what would be the savings? In unlined canal seepage loss would be more, and in lined canal that would be less. So the difference is a particular benefit for lined canal. Same as there are some other benefits also, S3. So the total amount of benefit would be S1 plus S2 plus S3. We have to see that this benefit always should be greater than the total cost that is included in providing a canal line. So the economics of lining says that the total benefit should always be greater than the cost induced, your cost incurred in providing a canal lining. Okay, so these were the second topic. These were the subparts of the second topic, that was about canal lining. I hope you got the clarity about each and every topic of the canal lining. If you have certain doubts, you can ask me at the group. Thank you.